Okay, so let's look at this question to review histogram. So we have 20 bags of sugar that were weighed. The weights in nearest kilogram as follows, and we're going to do a frequency table for the data. So what we're going to do, 3 would fall in this category, 38 would fall here, 17 here, 33 here, 28 here, 12 here, 43 here, 38 would fall here, 31 would fall here, 30 would fall here, 11 would fall here, 8 would come here, 23 would go here, 18 would go here, 26 would go here, 50 would go here, 22 would go here, 35 would come here, and 39 would come here, and 5 would go here. So the number of bags would be 3, 4, 5, 6, and 2. For the class interval 21 to 30, so if you recall, each of these would be class intervals. So they're asking us to look at 21 to 30. They want to know what is the upper class boundary. So what is the boundary? What is the highest that you could go to and still fall in that class? So the upper class boundary will be 30.5, because anything that hits that mark 30.5 has to fall into the next category, and just before 30.5 would stay in the category 21 to 30. The class width would be the upper boundary minus the lower boundary. So that would be 30.5 minus 20.5. So the class width is 10. And the class midpoint would be 21 plus 30 divided by 2, which will give us 51 over 2, which will give us 25.5. Okay, so now they want us to draw the histogram. And so to draw the histogram, they want us to use a scale on the x-axis and a scale on the y-axis. So let us first draw in an x-axis, and let us draw in a y-axis. Okay, the scale on the x-axis that they want us to use will measure the weight in kilograms. So the weight in kilograms, and they want us to use 2 centimeters to 10 kilograms. So every 2 centimeters, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2 would be 10 kilograms. So we get 10, 20, 30, 40, 50, 60. And on the y-axis, we are going to put the number of bags or the frequency. So we're going to put number of bags, which is the same thing as the frequency. And the scale that they want us to use there is 1 centimeter to 1 bag. So 1 centimeter, every centimeter would represent 1 bag. Right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So our scale, let's do that a little neater. Alright. So our scale would be x-axis 2 centimeters to 10 kilograms, and y-axis 1 centimeter to 1 bag. And our title would be the weight histogram showing of 20 bags of sugar. Now to draw the histogram, we are going to plot the upper boundary and the lower boundary against the frequency. So the lower boundary for this one is 0.5 and the upper boundary is 10.5, because everything that is between 0.5 and 10.5 falls in that class. So the lower boundary here will be 10.5 to 20.5. Then we'll go 20.5 to 30.5, 30.5, 40.5, and 40.5 to 50.5, because anything that is just 40.5 and over but just below 50.5 would fall in the class of 41 to 50. So now let us look at the drawing. So if from here to here it represents 10, then each of the small blocks represents 1. So if we want to draw 0.5, 0.5 will be halfway between the 0 and the 1. So therefore we want to take that and draw it up to 3, halfway between. And then 10.5 will be halfway between 10 and 11. Right, so we're trying to draw it halfway between. Halfway between is what you're looking for. And we come up to 3. The next one is 10.5 and 20.5 going up to 4. So 10.5, right, so halfway between 10 and 11 going up to 4, and 20.5 halfway between going up to 4. And so we see they end up joining, because the upper boundary of one class is the lower boundary of the other class. So the next one will be 20.5 going up to 5. So halfway between, not exactly on the 20 line, halfway between going up to 5. And then we have 30.5 going up to 5. So halfway between, and we have 30.5 going up to 5. 1, 2, 3, 4, 5. Right, so not on the line with 30, but halfway between 30 and 31. The next one is 30.5 going up to 6 and 40.5. So halfway between, and this time we're going up to 6, halfway between, and 40.5 going up to 6, halfway between, right, and it goes up to 6. And the last one is 40.5 and 50.5 going up to 2, right, so halfway between, and it goes up to 2. And that would be our histogram. And we just double check, we have labeled our axes, we've put in the scale, we've used the correct scale, and we've put in a proper title for the histogram. And that is how you do a histogram.